Caddis Maximus here. This is another installment in my little fan series. This was going to be a quick video about generally brands that if you see or if you're looking for them online are quality brands that I would trust. Now all these brands do make cheap fans which aren't the best. I always recommend higher power fans just because the higher power fans are a more premium product from any of the manufacturers. They tend to be a little better, bigger bearings, obviously more airflow, and if you're using fans that are of variable speed, say 4-wire fans, or you're adjusting the voltage to adjust their speed, you're just going to end up with more control of a higher power fan. And even if you're running at low speed in certain hot situations, obviously you can ramp up to move lots of air. That previous video with the Delta was using a higher power fan that could deal with a great deal of grid. Obviously a very cheap, thin Delta fan wouldn't have been able to, low amperage, deal with the amount of crud that I showed in that previous video. But of the higher grade fans, these are the brands I really trust. Obviously there's Delta Electronics. They really are the best. One of the big reasons is they make a big effort for their part numbers to actually show up on Google. And so it's very easy to search any old Delta fan and get all the statistics that you want from it. And of course, to give you a close look, here's what the Delta logo is. It's really distinctive, and of course it's always Delta Electronics. And like this little one, which is known as an 80mm fan, or about 3 1/8 inches. See, this is a nice one. So you would, one thing to look out for is thicker ones. Thinner ones are going to be weaker. But in like hand size or palm size fans, once the amperage starts getting around an amp or more, you know you're dealing with a nice fan. There are fans that are this size that are just, 0.1 amps and are pretty darn weak. And any old fan will work. But if you're looking for high performance fans, this is one of the top brands. Easy to find stats like this fan right here. That's the startup current. It runs around an amp continuously. And this little 3 1/8 inch fan will move 80 CFM, although with quite a bit of noise. Obviously, much higher performance fans will have this feature where they have the air vanes or the air straighteners on the back, such as this Sunon. They'll come in various voltages. This Sunon is 48 volts. Sunon is what I'd say is the lowest, towards the lower end of fans that I'd actually trust. There are DA-Tech and Everflow and a lot of other fan brands, and I've really not had very good luck with them. These are the brands that really a lot of commercial computer system servers use, as well as all sorts of industrial applications. So we have SanAce, which is Sanyo's version. This is actually a pretty nice one. This would be like anywhere from 150 to 200 cubic feet a minute would come out of this 120mm fan, which is about 4.5 inches. And SanAces are really excellent. They're using servers. Delta's big competition would be Nidec. Their big issue, what's wrong with my camera here? There we go. Where Delta, you can just look up their part number, and they actually make sense. They have like a range, and then these last 3 letters are actually the performance version, and surprisingly enough, that actually the EHE stands for extreme high end. But the 08 would mean that this is a 92mm fan and 12 volts. So, and other manufacturers just use terrible ones like this Nidec. It's a Nidec Beta 5 TA350DC, and then there's an actual model number, and it really is screwed up because you'll pull out a fan, think this is the model number, and there's actually a variety of different ones. Otherwise, Nidecs are very good quality fans, and even this little one's 2.3 amps. We can see at 12 volts that's going to be almost 30 watts. This is definitely a pretty nice fan. We can tell just looking at the front of it that it has 9 blades, where say a lesser fan would have something like this AVC, which I'd say was along the Sunon, where this is a 0.9 amp, which is pretty decent, but it's a 5 blade and it gives you a nice amount of flow with a reasonable amount of noise. But AVC makes nicer fans, and they really are good. Hewlett-Packard's really known for very high quality workstations and servers, and they'll use Nidec, Delta, and AVC fans. AVC is also really known for hydraulic bearing fans. Hydraulic bearing fans can last a long time and be very quiet, but they don't do good in harsh situations. So if you're building, any kind of a project, anywhere from like cooling situations on boats and marine, remote control cars, just all the different projects where it may be a vehicle in motion where fans are going to be jarred, you always really want to get ball bearing fans. And in the previous video I showed, they can take a lot of abuse. So we have AVC. Sunons are really pretty nice, But their division, they really sell a lot of their lower end fans. And they really do make some nice ones, like this 20 watt 48 volt fan. And all Sunnen seem to be made in Taiwan, where a lot of these have been moved to China. One thing I will say about Sunnen is they're really focused on balance. One of my biggest complaints with Delta fans is they last a long time. They're really just awesome fans, especially when you get the higher power ones. But they pump out so many fans that they're willing to deal with just putting in a little more oversized bearings, a little bigger motors, and some of them do vibrate. And so I have a lot of various Delta fans, and some of them are super smooth and some vibrate a bit, where every Sunnen I've had has always been really well balanced. We have EM Paps. They make all sorts of computer fans. This happens to be a 120 volt fan. I don't know why the camera's having such a hard time focusing here. And these are German made. So they make, computer size fans that just are 120 volt or 240 volt or 230 volt. They tend to be used in, they'll use them in copying machines and things like that. Ventilation fans and certain types of building applications, certain types of bathroom fans, I'm sure will use expensive ones. This company, Delta, actually makes the bathroom fans, and they're pretty well rated. And it's pretty wise. I mean, they built their company building these high-power computer fans, and then started using all their patents to go into other markets like home improvement. So these fans are not high power because they use an AC induction motor, so they can't deliver the type of power density that these brushless DC motors. All these other 12 volt fans are brushless DC and can apply a lot of torque. So these tend to have really large spindles in relation to their blades, so they don't move a ton of air, but they are super duper reliable and usually super quiet, and almost always, since they're 115 volt, have a metal housing on them. But that brand, EM Paps, is just excellent. And then we have NMB and a partnership. And this is what still confuses me, but these NMB fans are also really top end. They're really nice fans. Most times you'll see lower end ones because very few machines will actually get the higher power ones, like this 2.1 amp and this 2.5 amp. But they have fans that they've done in partnership with Matsushita, which is Panasonic, and then they're just straight up NMB branded ones, and both of those are just excellent. So this was just trying to be a fast video as possible, just talking about some of these different brand fans and how they're all really pretty nice. But these are the ones that I trust. If I'm using any sort of project, say I have one of those new switching power supply welders which have cooling fans in them, a lot of times the fans that come in that kind of equipment aren't the great. Even if you get a nice welder like a Miller, they won't have kind of extreme fans like I'm going to go through. So it's nice to have these to upgrade. And when I use any of these brands in like a welding machine, I'd feel totally confident these fans would last longer than the machine itself. All these fans shown here would last at least, have mean time between failures of 5 years plus of continuous 100% operation, never turning off for years. Which means in just about any other applications, like putting it into a switching power supply welder, the fan would last the life of the machine. I mean, just period. No welder's gonna, be run 24 hours a day for years and years on end. Some do, but not, the more portable switching ones, which seem to have these types of fans. And last but not least, a real quick thing for people who are, it doesn't matter if the fan, it does matter if it has 6 wires. Those are super rare. But most fans will either have 2 wires, which is positive and negative. They'll have 3 wires, the positive, negative, and a tachometer wire. And those are just fine. You just plug them into a power supply and you can vary the voltage in there. They'll run like normal. And then there are fans like these, which have 4 wires on them. And they're the same thing, positive, negative, a tachometer. And then one's what's known as a pulse wave speed controller. So the computers where the fans automatically speed up and slow down use the 4 wires. What's nice is they're redundant. So if you just plug in the positive and the negative, even on a 4-wire fan, the way it's set up is if there's no signal on the speed control, it just assumes that there's some issue, and so the fans always just ramp up to full speed. And to finish this video off, I'm going to do it pretty quick and dirty here. I'm going to pause and plug in and try out 3 of these fans. I'll do the Delta I'll do the Sand Ace, and then I'll do the Big Sunin. Just so people can have, every video I'm going to run at least a couple of fans. I'm not going to run all these, but just so anybody who gets to the end of this video and kind of is curious about how much noise a few of these random ones makes. Just a second here. Whoop. Okay, here we go. This is going to be this Delta here, and there's up close. This is 80 cubic feet a minute out of a fan that's 3 1/8 inches, or 80 millimeters, by 38 millimeters, or 1.5 inches thick. The vanes really help more air to go through because it causes it to be sheared between the vanes and what's coming off the back of the blades. It also has another effect of it creates more of an air tunnel. So the air coming off the back of this actually blows pretty in a fairly confined area. And here's this Sand Ace. The reason I know about the Delta, as I was talking at the beginning of the video, it's easy to search for their part numbers and get the data sheets. I know that's an 80 CFM fan at the amount of noise you heard. Things like the Sand Ace, you search Google for this number and it's impossible. You have to get all the manufacturer PDFs and hunt through the PDFs. It's a big issue. Delta is really smart. When you search online, like this fan here, DigiKey, which is like the Amazon of electronic parts, has 1,000 of them in stock, to give you an idea. Where on the Sand Ace, I can't find anything except for a few used ones. Although because of that, they're pretty cheap. I'm sure these fans were pretty expensive. This Delta here is like $18, $17 or $18. This Sand Ace can be found for $12, even though it's a much more expensive fan with a cast aluminum frame, due to the fact that nobody knows about them. And they just don't show up in searches, and so people don't, buy them and realize how good they are. So this is easily going to be twice as much airflow. This is going to be 150 to 200 CFM. It's a 22 watt fan. So you can tell that fan is actually a bit noisier than this one. It's moving quite a bit of air. And they even have like these little kind of air straighteners, but it's kind of a compromise. It doesn't have those vanes. These types of fans won't clog up quite like these. These vanes here tend to get dust caught on top of them. So fans like this, you can still get pretty high airflow. Makes a little bit more noise, but because of the big openings, it's very difficult for these to ever get clogged to such a point that they won't move a significant amount of air. And as I mentioned, you always want to be super careful. We can see on like the Sanyo, we can see how good a quality is. There's like this weird kind of surface finish you can see on the blades. And that isn't roughness. That's because this is fiberglass reinforced PPE. And we know that for a fact because it actually has it stamped on there. Whenever they have a plastic, they'll have the type of plastic it is, PPE, and then just GF20 is glass fiber. So the blades on this fan are fiberglass reinforced, so very nice. And we can see that they use a brass center, which just helps with balance, gives a little bit more mass to the rotor to reduce vibration. And so those are some of the other qualities. Cheap fans, they won't give you these brass kind of hubs, and certainly not fiberglass reinforced blades. Okay, last fan. And here we have the Sunin, which surprisingly enough uses a little bit less power than the Sand Ace. They probably both spin at the same RPM. I'd have to use an optical measuring tool. But the difference here with the Sunin, and they both have the same number of blades. Actually, the Sunin is a 9 blade, and this is a 7 blade. And so this is actually going to move a little bit more air because there are more blades to chop through it. And it has these rear vanes, but it's going to make more noise. That's a big sacrifice. This fan's easily 200 to 250 CFM, and they can move quite a bit of air through one of these, which is a 120 millimeter or a 4.5 inch fan. So that was just a quick demonstration to give you an idea of how much noise different size fans, different blade counts, and even similar power levels, and just different aerodynamic designs affect the airflow, and it's all relation, power, airflow, noise, and then the pressure level that these can work against. The fans that do have these vanes can work against a greater restrictor. They can pull through a thicker filter than, say, a fan like of these style. Anyway, this is already a blithering 15-minute video. And just to show, we'll get more into them. They make high-power blower fans like these, and of course, all sorts of sizes of those 115-volt fans, which are better in the larger sizes, and we'll get into that in future videos. Anyway, I really appreciate everybody who does watch and subscribe my channel, particularly these more esoteric videos like about fans. And if you haven't subscribed, please do subscribe to the Catus Maximus channel. Until next time, Catus Maximus out.